Hello everyone. So in today's session, we will see what is degeneracy in a transportation problem. In the previous sessions on transportation problem, we might have seen when we come across with the basic feasible solution, we used to check this whether the number of allocations in the problem is equal to m plus n minus 1 or not, where m is the number of rows, n is the number of columns. So whether after adding those two and then subtracting with 1, whether the number of allocation matches with this or not. Suppose if it is not matching or if it is lesser than this m plus n minus 1, then that time we say that the problem has a degeneracy in it. So in order to understand about this degeneracy, we'll go with a numerical problem wherein we will come across with this particular degeneracy thing. So let's move on to the question. Consider the problem of allocating raw materials from 4 different warehouses to 5 different plants. The availability of the raw material in the 4 warehouses and the demand of the raw material in the 5 plants are given in the following table. It is not possible to ship the raw material from warehouse 4 to plant 4 because of steep road. So this particular thing, this we are coming across with this thing for the first time. So basically this is about a restriction which is being given. Means the transportation should not happen from warehouse 4 to plant 4. So there is a restriction in this particular question. Then from the unit cost of transportation, which are given in terms of hundreds in the table, we need to find out the initial basic feasible solution. And the question has specified that we should use least cost method. So let us proceed to the table. This is the table. There are 4 warehouses and there are 5 plants. And for each warehouse to plant, how much will be the unit transportation cost is being given. For example, from 3rd warehouse to 2nd plant, if I have to transport, I'll be incurring 5 per unit as the transportation cost. Then in this question, the demands for various demand from various plants are given, and then supplies available from various warehouses are also given, and the total of that is the same, 105 only. So basically this is a balanced transportation problem. So how do we proceed with the solution? First thing what we do checking is sum of supply, is it equal to sum of demand? Already we had seen the table itself specifies the total is 105. So since the supply, sum of the supply is equal to sum of the demand, this given problem is a balanced one. Further, already the matrix what is given in the question is a cost matrix. So naturally our objective will be to minimize the total cost. So that means what? Once these 2 conditions are satisfied, means the question given is a balanced one and it is a minimization method. So we don't need to do anything else. Directly we can start using the algorithm. Here we have been told in the question that we are supposed to use the least cost method to find the initial basic feasible solution. So let us proceed. So a table, same table, whatever is given in the question. So now we will start using the least cost method. So how do we do it? Among all the costs, cost means these numbers what is written in smaller size, 10, 2, 3, 15, 9, 5, 10, all these are the costs, transportation costs. We are supposed to choose the least cost cell. So among all these costs, we may notice that the least cost is 2. Yeah. Before proceeding further, we may notice that they didn't give us any cost for the transporting from warehouse 4 to plant 4. Why? Because it is restricted. Means they say you should not do any transportation from warehouse 4 to plant 4. That is given as a restriction in the question. That means I am not supposed to do any allocation to this particular cell. How can I avoid doing any allocation in this least cost method? We will definitely not do any allocation to any particular cell if the cost is very, very high. So what we will do, we will define this particular cost for this cell as, say, capital M. And then we say this capital M is tending to infinity. Means the cost is so large that even by using least cost or whatever Vogel's approximation method also, that algorithm will avoid us not to do any allocation because M, we know it is approaching infinity or it is a large number, right? So that is the first step. Now let us identify what is the least cost among all. In the first row, the least is 2. Second row, the least is 2. Third row, the least is 5. And the last row, the least is 8. So among all this least costs, the most least is 2 only, which is occurring in 2 places, here also and here also. Suppose if I consider this 2, then the allocation will be the least of 20 and 25, which means I can able to allocate 20 units here. Whereas if I choose this 2, 10 or 30, that means we'll be able to allocate 10 units. So it is better, let us choose the quantity which is higher, that is 20 units. So we will be doing our first allocation to this cell. Since I allocated 20, no more allocation possible here, no more possible here, no more possible here. Let's close it. Since 20 is already being allocated, this 25 needs to be reduced to 25 minus 20, so it becomes 5. So we know, again, the least cost is 2 only because we found that time 2 places 2 was occurring. So we will come here, 10 or 30, we will allocate 10 here. Since 10 is allocated, no more allocation here, no more here, no more here. This 10 will be closed. Since 10 is already done, this 30 will reduce to now 20. Then the next least cost is, it is 3. And 3 is occurring in only one place, this place only. So let us do our allocation here. When I come here, I'll compare the supply quantity and demand quantity, which is 5 and 30, and you will allocate whichever is the least. So we'll allocate 5 here. Since 5 is fully allocated, I need to close this, close this, close this. Since 5 is already allocated, this 30 will now reduce to 25. Okay, the next least cost. Now the next least cost is 4, which is available here only one place, not in more than one place. So here when you come, you will compare the supply and demand. Supply is 20 and demand is 25. So we will allocate here 20. Since 20 is fully done, close this, close this, close this. Since 20 is already done, this 25 will be reduced to 5. Now the least cost is what? 15, 14, 15, 20, 13, 8. That means the least cost is now 8. So we need to allocate to this cell. So when I come to this cell, the demand quantity is 5 and supply quantity is 30. So we'll allocate 5 here. Since 5 is fully done, this has to be closed, this has to be closed, and this 30 has to be reduced to 25. Now, these are the cells which are left, that is 15, 14, 20, 13. Least cost is 13. So when you come to this particular cell, you compare the demand and supply, both are same, 25 and 25. So allocate 25 here. Since I allocated 25 fully, I have to close this, close this. Since this 25 is also fully allocated here, I need to close this also, close this also. Now only one cell is left, which is this 15. So when you compare demand and supply, both are 20 and 20. So allocate 20 here. Since 20 is fully done, close this, close this. So all the cells are exhausted, means you have already done all the allocations. So now let us find out what should be our M plus N minus 1. M means number of rows, there are 4 rows, and N means number of columns, it is 5 columns. That means we are supposed to have 8 allocations. We are supposed to have 8 allocations. But how many we have got? 1, this is this 21, this 2, 3, 4, 5, 6, 7. So we actually got only 7 allocations. So we will write here, we obtained only 7 allocations. Means degeneracy exists. Degeneracy exists in this problem. So in this session, we are not going to see how do we get rid of this degeneracy. That we will do that in our next video. So today what we did, actually, to understand degeneracy, what do we mean by degeneracy? If m plus n minus 1 is actually some number and the actual allocations are less than this m plus n minus 1, then we can conclude that that particular problem has got a degeneracy in it. Then this problem has also got a restriction, like some particular source point to a destination point is not being allowed due to some reasons. Then how do we approach it? That also we understood. We assign a alphabet called capital M, and then we say that capital M is approaching infinity or tends to infinity. Means that particular cell, any allocation needs to be avoided. That is the reason we are considering that particular M as tending to infinity. So that also we understood. Then the question has specifically told us to use least cost method. We had used that least cost method and we landed up having only around 7 allocations instead of the required 8 number of allocations. So we concluded that this particular problem degeneracy is existing, or this particular problem has got a degeneracy. How to get rid of this degeneracy and proceed with optimal, we will see in our next video session. In the meantime, I thank you all. In case if you like this content of this video, I request you to please like it, share it with your friends, and also subscribe to my channel so that you will get regular updates about my various videos. Thanking you all. See you in the next session.